Welcome to Talking to AI about AI. I've taken to talking to AI in the car, dialing back the playlists and podcasts. We work through ideas on business, my art, and realistic, and sometimes far-reaching use cases. Today, we're diving into fraud detection using AI and what that might look like in a few simple examples. If you're wondering, this is my actual conversation with a chatbot where we verbally talk back and forth. What you're listening to is a slimmed down transcript just to cut down on the time, but it is the actual discussion then fed through text, voice, and AI to generate what you're hearing. This is my clone voice and a completely made up collaborator voice.
That collaborator's me, by the way.
Indeed. Let's dive in. I'm excited to have this chat with you today about fraud detection. It's a topic that's increasingly relevant across so many sectors, isn't it?
Absolutely. And it's great to be part of this conversation. Fraud detection is definitely a critical area where AI can play a role. Really, in any industry, this is a concern. AI's ability to analyze patterns and behaviors can be a game changer.
I know that fraud is a key role or team or department in a lot of different kinds of businesses. I recently saw a job post actually for a fraud expert for Ancestry.com, which I thought was interesting. I hadn't really thought about it before, but I guess you wouldn't want people fudging someone's lineage, perhaps. So maybe let's talk about this.
Yeah, of course, many companies need to be watching their business closely, especially now that with AI, fraud can be a much larger concern. Where did you want to start?
I worked at a company ages ago. It was a gig economy shipping marketplace. Like if you need to ship your couch to your grandma in Iowa, you might use our platform to find a carrier. Somebody to pick up the couch, drive it to your grandma, and drop it off. Fraud prevention was a big deal there. People could use the platform to launder money or all kinds of other various things, right?
Yeah, for sure.
Often these people aren't super clever. The fraudsters, not our fraud team, they might act as both the person with the couch and the carrier or service provider. They put the couch on the platform. 3 seconds later, they accept the couch as a load, then immediately pay for the shipment, calling it completed as if the whole thing happened within a matter of seconds, right? Money goes into the platform, then they take money out, nicely laundered.
Yeah, super common.
So we had a whole department around keeping up with this behavior, canceling loads and accounts, refunding money, you name it. I suspect AI could probably have helped here. Let's talk a little bit about how you see AI helping in this case. First, from a use case perspective, and then we can dig into some of the implementations.
Your example of fraud detection in a shipping platform is a great scenario to explore. AI can be incredibly effective at identifying and preventing these activities. There are a few use cases we can consider. First, pattern recognition, identifying patterns in data that might be indicative of fraud. Like the example you provided of a couch being listed, shipped, and delivered in an implausibly short time. Anomaly detection, flagging data or activities that deviate significantly from the norm. Next, network analysis, exploring relationships between different accounts to identify networks of fraudulent actors. If the same groups of accounts are frequently interacting in suspicious ways, this could indicate coordinated fraud. If one of these accounts, one that on its own looks completely normal, starts interacting with a new account, it might trigger the AI to look closer at this new account. Finally, predictive analysis, using historical data, predict the likelihood of fraud in certain scenarios like particular routes, item types, or transaction values. Now, to be effective, the AI system would need access to a wide range of data, may need to operate in real time, and leverage adaptive learning since fraudsters are constantly changing their tactics. Additionally, while AI can handle a lot of the heavy lifting, human oversight is crucial. This ensures that flag cases are reviewed and that the system is not producing false positives.
Let's talk about the idea of continuous learning. There's often very obvious ways non-clever fraudsters can be identified. Like in the example of shipping something in an implausibly short time, but people eventually get more and more clever. How does an AI model identify new patterns and then remember those new patterns? I imagine that initially the AI would be trained on some data set. You might use RAG to be able to incorporate new ideas as they come, but that's a manual process. How could an AI itself learn and take action as it sees new situations emerging?
You've touched on a crucial aspect of AI and fraud detection, the ability to continuously learn and adapt to new tactics used by fraudsters. There are several key mechanisms and technologies working together that we can get into. Fraud models use machine learning to learn from data that it's initially trained on, including both legitimate and fraudulent activities to develop right and wrong behaviors. The AI system must continuously update its understanding based on new data. Feedback loops are critical, like which transactions were confirmed as fraudulent, so it can refine its algorithms, improving accuracy over time. And the use of unsupervised learning algorithms for anomaly detection, identifying unusual patterns or outliers in the data, possibly indicating new types of fraud. Human experts play a crucial role in identifying new fraud patterns, labeling this data and feeding it back into the AI system. An AI approach can also transfer learning, or a combination of different machine learning models referred to as ensemble methods, to improve the system's ability to detect and react to complex fraud schemes. By integrating these methods, an AI system in fraud detection can continuously evolve, becoming more sophisticated and effective in identifying and preventing fraudulent activities as new tactics emerge.
You say that fraud detection is likely to use machine learning. I know this may seem like a dumb question, but tell me more about how machine learning compares to a language model like ChatGPT or GPT-4 rather.
Sure, let's break down the basics of machine learning and how it's used in fraud detection compared to language models. Machine learning now in fraud detection analyzes data to identify patterns that indicate fraudulent activity. It looks for anomalies or unusual behaviors that deviate from the norm. Language models are trained to understand and generate human-like text. They can answer questions, write essays, generate creative stories, etc. Human models are trained with a specific dataset or something specific you are wanting to teach it. In fraud, this includes both legitimate and fraudulent transactions. The model learns to differentiate between these two based on various features like transaction amount, frequency, location, etc. Language models are trained on a massive data set of fairly general text. They learn patterns in language and how to generate coherent and contextually relevant responses. It's much more general, typically. So machine learning is really about the learning, teaching a model to react in certain ways, do certain functions in certain situations, etc. A language model, even if that model was trained on specific data, is really focused on providing language-based responses. In our case, the two would work together to take actions and respond back in ways humans can understand.
Okay, that makes sense. Maybe let's dive deep into the human-AI collaboration. Let's explore that a little bit. Give me an example of how that might play out in the real world.
Absolutely. Let's consider an online retail platform. Imagine a retail marketplace where both buyers and sellers transact. Fraudulent activities here might include fake listings, scam transactions, or identity theft. The AI system continuously monitors transactions and user activities. It would flag potential fraud based on patterns like unusual transaction sizes, rapid account creation, or atypical communication patterns. If a new account suddenly makes high-value purchases, or a seller account changes its bank details and immediately requests a large withdrawal, these are flagged for review. Transactions or accounts may get a risk score based on various factors. Higher scores indicate a higher likelihood of fraud and are prioritized for review. This is where the human comes in. When the AI flags something, it's routed to human analysts. These experts review the details, considering nuances and context that the AI might miss. For example, a sudden increase in sales could be due to a legitimate promotional event. The conclusions and actions of the human analysts, like confirming a fraud case or marking it as a false positive, are fed back into the AI system. This feedback helps the AI learn and improve its accuracy.
This sounds a little bit like reinforcement learning from human feedback. Is that just coincidence? Are they just similar, but not actually the same?
Your observation is quite perceptive. The scenario I described does indeed resemble reinforcement learning from human feedback, known as LLHF, although there are subtle differences. In RLHF, an AI model learns from human feedback, but this feedback is typically more direct and integral to the learning process. It's akin to training an AI by rewarding desired behaviors and penalizing undesired ones based on human evaluations. In the collaborative fraud detection example, the AI system primarily learns from pre-labeled data, supervised learning, to recognize patterns of fraud. Human feedback comes into play when analysts review and provide insights on the AI's decisions, which is then used to refine the model. Here, the human feedback is more about correcting and updating the AI's understanding based on specific cases or broader policy changes rather than shaping behavior through reinforcement. In essence, while they share the concept of AI learning from humans, the methodologies and contexts in which they are applied can differ.
In the fraud case, where humans and AI are working together, I assume that mechanism is some custom application that allows the user, the admin, the ability to review the details and to take some action. And maybe a bit further, sounds like this custom application is plugged into this retail marketplace. Perhaps a specific transaction as well as machine learning somehow and provides the user-specific actions or functions.
Yes, you're exactly right. In a fraud detection system where AI and humans collaborate, there's typically a custom application that facilitates this interaction. Yeah. Bridge between the AI's automated analysis and the human expert's decision-making process. The AI system flags potentially fraudulent activities based on its analysis. These flags are then sent as alerts to the custom application. Human analysts access these alerts and relevant information like transaction details, reasons for flagging, user history, and any relevant patterns identified by the AI. The application usually includes tools to make decisions or take manual actions. For instance, they can approve the transaction, mark it as fraud, or escalate it for further investigation. Crucially, the application often includes a way for the analyst to provide feedback on the AI's performance. This could be as simple as indicating whether the AI's suspicion was correct or not. That feedback is then used to update and refine the AI model. This way, the AI system learns over time, improving its accuracy and reducing false positives.
Interesting. So this fraud AI model is going to see some suspicious activity and send a message to this custom application that the human uses. But the AI is watching for all kinds of activities, or even might see something it doesn't understand and consider suspicious. How does it know what information to send to the custom application? And how does it say what a human can do or what actions they can take?
Configuring the flow of information from the AI model to the custom application in a user-friendly and actionable manner involves several key steps. But remember, the custom application and the messaging is just normal application development, and you can define the UI controls, the inputs and outputs, however you want in standard ways. Sending information to these structured messages would involve training the model to send data in a specified way for all known activities. Even with a suspicious new activity, you would train the model to gather the data, understands the reason it deemed it suspicious, and send it in a way the custom application expects. There are several things you may want to take into consideration, however. First, defining relevant data. Identify key information for analysts like transaction details, account history, and AI detected patterns. Second, data formatting. Structure the AI outputs into readable reports or summaries for easy interpretation. Next, integration with messaging services. Use technologies like RabbitMQ or Amazon's simple notification service to send alerts to the application in real time. And customizable dashboards allow admins to view and interact with alerts on a dashboard with options for customization. Drill down options. Provide detailed views of alerts, including transaction history and other attributes. And configuration settings. Enable admins to set display preferences in the application. Finally, to user feedback for improvement and iterative development. Collect user feedback on data presentation for continuous enhancement. Start with expert-based configurations and refine based on user interaction and feedback. In essence, the design of this communication and data presentation is user-centric, focusing on providing relevant, understandable, and actionable information to the human analyst with flexibility for customization and continuous improvement.
Okay, so it sounds like this back and forth orchestration is defined when you are initially creating the fraud detection model with instructions, including how to detect certain understood patterns and then what to do with it once a situation is detected and how the communication should look. This would vary from case to case.
Correct.
Now, the AI would need real-time data sent to it so it can analyze activities as they're happening. So in this example, the retail marketplace, which is outside the AI, would need to send its data as it's happening or on some regular interval, I suppose, to the AI, right?
That's right.
Then the AI's instructions might label some activity or transaction as a particular fraud pattern, and then format certain information and details in a particular way to be sent to the custom application.
Yep. And this would vary from one activity to the next.
Likewise, one might also instruct the model on how to provide more detailed information if needed. I imagine this is where a more general language model might come in handy.
Yeah, and obviously iteration is important because your first stab might not have included all the use cases and potential nefarious activities, nor all the information you might later want to collect.
Got it.
In essence, the AI model's development for fraud detection includes not just the detection algorithms, but also a comprehensive plan for how it communicates its findings and interacts with human analysts. This setup is dynamic and evolves with ongoing use and feedback, ensuring that the system remains effective and user-friendly.
That makes a lot of sense. I'm getting a clearer picture of what's happening here. I would imagine expanding from there that the final decision to say something is not fraudulent partly. It is labeling the activity, but also integration with the non-AI platform, for example, to allow a transaction to go through or lock an account, add additional notes or comments, etc. That makes sense to me. But I want to know a little bit more about the learning part. As the admin is confirming or refuting possible fraud activities, how does that feed back into evolving the AI model?
Let's dive into how the AI learns from these interactions and incorporates new insights into its model. Think of this as a workflow. First, a human analyst identifies an action as fraudulent or not. This outcome, along with any additional comments or insights, is captured by the system. This might involve marking the transaction, annotating reasons for the decision, and providing additional context. These human decisions effectively serve as new labels for the data. The newly labeled instances are added to the training data set. Over time, as more data is collected and labeled, the data set grows and becomes more representative of the real-world scenarios the AI encounters. Then there are a couple of approaches for retraining or fine-tuning the model. One way is incremental learning. The AI model is updated with new data in real time or near real time. This approach is more dynamic and keeps the model current, but requires careful monitoring to prevent model drift. Another way is periodic retraining. The AI model is retrained at regular intervals with the updated data set. This ensures the model is learning from the most recent and relevant data, including the insights gained from human analysts.
Okay, so this custom application is storing what the human admin entered, if the event was actually fraudulent or not, saving that to the original data set, and then at some point, the new data set is used to retrain them. So the flow is, an event happens, message is sent to custom application, human does some stuff, local data set is updated with new event and human stuff. Then finally, that new data set is used to update the model. That's the full cycle.
Keep in mind, there are a few other steps to consider. Sometimes new types of fraud or unexpected legitimate behaviors are identified. This may require adding new features, data inputs to the model, or adjusting how existing features are weighed. After retraining, the updated model should be tested and validated to ensure it performs better than the previous version, especially in terms of reducing false positives and false negatives. Once validated, the updated model is deployed to replace the older version. This deployment needs to be seamless to ensure continuous operation of the fraud detection system. Even after deployment, the performance of the model is continuously monitored. This ensures that it adapts well to the evolving patterns of legitimate and fraudulent activities. Basically, the learning process is iterative and involves a continuous cycle of capturing human decisions, updating the training data, retraining the model, and deploying improvements. This process ensures that the AI system remains effective and up to date with the latest trends and patterns in fraud.
Okay. So new learnings aren't really learned by the model until one retrains the model. So I want to be clear about something. It sounds like when your fraud model detects some new potential fraud, sends it to a human, the human reacts.
Yes.
It's fraud or no, it's not. That whole flow will repeat if something identical happens moments later, right? Like before the next retraining happens. It didn't learn immediately from that first interaction. And it won't learn from any number of events that are identical until somebody goes and retrains the model, provided someone added data on this activity to the training data set. Is that correct? And is there a way to have that real-time learning happen?
Yeah, that's correct. And yes, there can be real-time or near real-time updates, but let's clarify and expand on a couple points. In post-deployment learning, the model only learns and updates its understanding after it's been retrained with the newly accumulated data, which includes the recent decisions made by human analysts. Implementing real-time learning is more complex but possible. This is where concepts like online learning or incremental learning come into play.
Online learning?
In online learning, the model is continuously updated on the fly as new data comes in. This approach allows the model to adapt quickly to new patterns, but it requires a robust setup to ensure model stability and prevent negative feedback loops. One challenge with real-time learning is ensuring the quality and reliability of the data used for updates. Immediate updates based on single instances might lead to overfitting or erratic behavior if the new data is not representative or if it's an outlier. Another challenge is computational. Continuously updating a complex model in real time can be resource intensive. A practical approach often used is a hybrid model where the system combines periodic retraining with some elements of real-time updates. For instance, certain aspects of the model might be updated more frequently, like adjusting thresholds or weights, while the core algorithm is updated less frequently. This allows for a balance between adaptability and stability.
It strikes me that this opens up a potential crack. It seems like if a model is not updated quickly, then somebody might use that fact to their advantage to find ways around it. Like in one case, a very squishy, ambiguous action might be flagged but one admin might not let it go through, but other might. Or maybe there's a 1 in X chance that an admin will miss a minor detail. Somebody trying to game the system might detect that this new situation could be attempted, and then try it again and again and again and again, waiting for some poor admin to make the wrong choice.
This is true.
And in another case, a fraudster might try to chip around a potential flaw. They run some situation, it's flagged and rejected. Try it again with slightly different piece of information. Again and again, iterating and tweaking minor little details, trying to find the actual gap. And if that fraudster is using AI on their side, it could do this rapidly and with extreme cleverness. I might be able to find a way to exploit a gap before it's been fixed. Does this seem like a potential issue to you?
Yes, you've identified a very real and significant challenge in AI-driven fraud detection systems. The potential for exploitation due to the time lag in updating models and the variability in human decision-making. Fraudsters may indeed try multiple attempts, banking on eventually encountering a more lenient or less attentive admin or methodically testing the system to find vulnerabilities. Continuous monitoring is crucial. There are some strategies to combat these challenges. First, a layered defense. Rather than relying solely on AI, implement multiple layers of defense, including rule-based checks, anomaly detection, and manual reviews. Then there's behavioral analysis. Analyze user behavior, like navigation patterns, speed, or out-of-character actions. Finally, there's adaptive mechanisms. Investing in a dynamic infrastructure that can be updated frequently can help in staying ahead of fraudsters. While AI-driven fraud detection systems are powerful, they are not foolproof. The potential for exploitation exists, and it requires a combination of technology, vigilant human oversight, and continuous adaptation to stay ahead of increasingly sophisticated fraud tactics.
You brought something up that I think is interesting, the idea of layering things together. If the same flag or label under similar conditions is being set several times, the custom application can take some action on its own, like automatically reject something or escalate notifications. It doesn't have to come from the AI. It seems it could also be a partner AI that is trained specifically on how to identify these kinds of attacks where details aren't understood but seems very suspicious. So let that second partner AI figure out what might be done.
Absolutely. Your idea of a layered approach with an additional AI layer to track and identify patterns in flagged events is a powerful strategy in fraud detection. This adds an extra dimension of security by monitoring not just individual transactions, but also patterns and trends over time. This secondary AI layer specifically looks for patterns in the flagged transactions. It analyzes frequency, similarities in the nature of the transactions, and any commonalities in the accounts involved. Alerts could be aggregated to present a clearer picture to the admin. For instance, show that a particular type of transaction has been flagged multiple times in a short period, suggesting a coordinated attack or a new fraud method. A sudden spike in certain types of flags, even if they're individually dismissed, might indicate an emerging threat. Based on the analysis, this AI can trigger dynamic responses like automatically initiating heightened security measures. The insights and patterns identified by this layer can be fed back to the primary fraud detection AI. This can help in quicker updating of the main AI model. Despite the additional AI layer, human oversight and continuous improvement are crucial.
This is very helpful. Thanks for walking me through some of this fraud business. I can see how this conversation could go on for some time, but has given me a lot to think about.
You're very welcome. I'm glad the conversation was helpful and provided you with valuable insights into the complexities and possibilities of AI and fraud detection. It's indeed a deep and evolving field with many fascinating aspects to explore. If you ever have more questions or want to delve into another topic, feel free to reach out. Happy thinking and best of luck with your endeavors in this area.
And that wraps up today's episode of Talking to AI about AI. We've navigated through the intricate world of AI in fraud detection, exploring how it learns, adapts, and collaborates with human insight to tackle increasingly sophisticated fraudulent activities. It's a realm where AI not only learns from data, but evolves with human interaction, blending the best of both worlds to strengthen our defenses against fraud. Remember, The field of AI is vast and ever changing, and we're just scratching the surface. If you found our discussion enlightening and want to dive deeper into the world of AI, make sure to subscribe, and follow us for more insightful episodes. Your support helps us keep these conversations going. Until next time, keep questioning, keep learning, and stay curious about the AI journey. Thanks for tuning in.